Hi everyone, I'm Harikrishna Menon and I'm a Program Manager in the XAML Tools team in Visual Studio and Blend. Today, I'm going to demo the energy consumption tool in the Performance and Diagnostics Hub in Visual Studio 2013. The objective of the demo is for me to show you how to use the energy consumption tool and help you understand how display, CPU, and network affect the energy consumption of your application. Nowadays, you get devices with bigger screens, brighter displays, and faster processors. So it's completely up to you to ensure that your applications offer the best possible experience to your customers in this regard. Now let's take a look at the energy consumption tool. As you can see, I have a session of Visual Studio open. There is a Movies app here that I'm going to use to demo this particular tool. I'm going to go to the Analyze menu. You can see there's an option for Performance and Diagnostics here. You can also choose to open it using the keyboard shortcut Alt F2. You can see that Movies was selected as a startup project automatically. You can choose to change the target by using this combo box. You can choose to change the deploy target using the target dropdown. You can see that there are 3 profiling tools available for XAML-based applications in Visual Studio 2013: CPU sampling, energy consumption, and XAML UI responsiveness. I'm going to select energy consumption and hit start. At this point, the profiler launches my application. As you can see, my application is a very simple Movies app that gets data from Flixster. I'm going to select one of these movies. You can see that I populate the screen with data from Movies now. I'm going to play one of these trailers. I'm going to stop playing, switch back to Visual Studio, and hit Stop Collection. At this point, the profiler has gathered a lot of information about your app and starts analyzing it. Once it's done analyzing, it'll show the summary view. Let's take a look at the ruler section. You can see that there are 2 kinds of marks here: App Lifecycle Mark and User Mark. The App Lifecycle Mark chronicles application events in your app. For example, things like when your application was activated, when it was launched, etc. User Mark is generated by user code. There is a new API in Windows 8.1 that can be used to log user information from within an app. This information is spewed out as ETW events and can be intercepted by the profiler and shown in the ruler. Hovering over these user messages, I can see that it shows, hey, I'm in the movie page at 16.62 seconds. This is super useful in isolating time slices that you want to profile in your app. For example, if I want to see the energy consumption in my Movies page, I can insert a user mark while navigating to the page and when navigating away from the page. Now let's take a look at the estimated power usage graph. You can see that there are 4 series here. You have total, CPU, display, and network. The value of total is generated from a power model. We have empirically determined that CPU, display, and network are the 3 biggest factors that contribute towards power consumption in your application. Let's take a look at CPU now. CPU is plotted using the yellow line. While hovering over this, I can see that, hey, at this point, CPU consumed 5968 milliwatts of power. I can select portions of this graph, inspect it. I can choose to zoom in and look at it at higher fidelity. I'm going to zoom out now using the Reset Zoom button. So it's generally recommended that you do a large amount of work in big blocks. This helps CPU accomplish a lot of work and go back to its idle state. If there are a large number of cycles where the CPU powers up and goes back to idle, it might consume more power. Display is another factor that consumes a lot of power in applications. It is well known that displaying lighter or bright colors takes more power than displaying dark or black colors. So it's an optimization you could do where by default you only show the dark theme to the customer and let him choose a lighter theme if he wants it. Finally, let's take a look at network. As you can see, in the bottom portion of the graph, you can see that the Wi-Fi network has a whole bunch of blue bars around it. This means it shows the active cycles of the Wi-Fi radio. Expanding the Wi-Fi network, I can see data transfer that happened when the Wi-Fi radio was active. One optimization you could do here is bunch as many as transfer requests together so they happen within one Wi-Fi active idle cycle. This eliminates the Wi-Fi radio from having to start and stop multiple times, which might consume more power. Finally, the donut graph on the left shows in percentage the total values of display, power, and network power consumption in your application. As you can see here, 57% of the total power is consumed by display, 35% by CPU, and 8% by network. We also calculate how long will a standard device run out of charge while executing an application based on our power model. As you can see, this application will cause a device to run out of power in approximately 7.45 hours. I hope you find the energy consumption tool helpful in making your apps fast and performant. We would love to hear more from you. You can send your ideas via user voice or Visual Studio feedback.